Hey everyone, welcome back. Today we're jumping right into a brand new explainer, and we're looking at something that is absolutely critical, yet somehow it often gets completely overlooked when we talk about the electric utility sector. We're digging into the SASB framework, the Sustainability Accounting Standards Board, specifically looking at how electric utilities and power generators manage a massive industrial paradox, coal ash. It's this wild story of hidden risks, really surprising rewards, and the specific accounting metrics that actually hold the industry accountable.
So, I want you to think about this for a second. We spend so much time talking about greenhouse gases going up into the atmosphere, right? But what actually happens to the physical, solid waste that's left behind? Electricity generation is one of the most resource-intensive industries out there, and burning coal produces literally one of the largest industrial waste streams on the entire planet. We're talking millions upon millions of metric tons of ash. Where on earth does it all go? How is it tracked? And maybe most importantly, how do we measure the hidden dangers and the potential hidden value of the grid's dirtiest leftover? All right, here's our roadmap for this explainer. 1. The coal ash problem. 2. From waste to wealth. 3. Tracking the metric tons. 4. Calculating percentage recycled. And 5. Policies for safe management. Let's get into it. Okay, Section 1. The coal ash problem. First things first, we need to define what we're actually talking about here. In the SASB standard, coal ash is formally called coal combustion products, or CCPs. And it's not just one uniform thing, it's really an umbrella term. When a power plant burns coal, you get a whole mix of byproducts. You've got fly ash, which is that super fine, powdery stuff that literally flies up the smokestack, but you also have heavier bottom ash, boiler slag, fluidized bed combustion ash, and flue gas desulfurization material. It's a highly complex, physical mixture, and knowing this vocabulary is super important, because we aren't just dealing with harmless dust here. These are heavily regulated materials. And here's exactly why they are so strictly regulated. Coal ash is packed with heavy metal contaminants that are linked to cancer and a host of other serious health issues. So the stakes, they are absolutely massive. If these coal ash storage pits, the impoundments, aren't safely located, monitored, and contained, those heavy metals can just leach right into the surrounding groundwater. For a power company, this isn't just an environmental nightmare, it's a colossal financial liability. We're talking severe harm to human health, massive litigation, and remediation costs that can completely tank a company's financial value. Which brings us to Section 2, from waste to wealth. This dichotomy is just fascinating. It perfectly captures the dual nature of coal ash. On one hand, you have this heavy, toxic reality, severe environmental liability, cancer risks, the threat of steep penalties. That's the risk. But then you flip it around and you have an incredible revenue opportunity. If this ash is properly recycled or reused, it turns out to be incredibly useful in construction and manufacturing. Fly ash, for example, makes incredibly durable concrete. Other CCPs are used to make wallboard. So suddenly, this massive toxic liability becomes a valuable raw material. Utilities can actually generate revenue while keeping hazardous waste out of local landfills. It's a real win-win when done right. Let's move to Section 3, tracking the metric tons. This is where we get into actually calculating the coal ash impact. The SASB standard, specifically code IFEU 1050A.1, creates an objective baseline for investors. It requires companies to disclose two very specific quantitative metrics. First, the total amount of CCPs generated, and second, the crucial percentage of those CCPs that actually gets recycled. And you can see how it's measured right there, metric tons for the total volume and a percentage for the recycling rate. I really want to emphasize that unit of measure for a second. 1 metric ton. When we're talking about the utility sector, we're dealing with millions of these tons. Every single metric ton that gets tracked, accounted for, and managed properly is one less ton sitting in some unlined pit threatening a community's drinking water. Tracking that absolute volume of metric tons generated gives investors and the public the true physical scale of the liability a specific company is dealing with. All right, Section 4, calculating percentage recycled. So how does a company actually calculate that crucial percentage? Well, the SASB standard gives a very specific formula for the numerator here. To count as recycled, the CCPs have to be converted into new materials or objects, real circularity that prevents waste. You get this number by adding up 3 distinct steps. Step 1, the weight of the ash that is directly reused or reclaimed. Step 2, the weight that the company recycles internally through their own treatment processes. And step 3,
the weight of the material they send or sell to a third party for external recycling. Once you add up the weight from those three actions, reused, internally recycled, and externally recycled, you divide that sum by the total metric tons generated. That gives you the golden number, the percentage of materials successfully diverted to beneficial use. If a company has a high percentage here, it means they are successfully flipping an environmental risk into an economic reward. But if a huge chunk of that waste remains unrecycled, that is a massive, growing, and frankly dangerous liability just sitting squarely on their balance sheet. Finally, Section 5, Policies for Safe Management. So what happens to the ash that falls into that unrecycled category, the stuff that just can't be turned into concrete or wallboard? Well, you can't just dump it and forget about it. The SASB framework mandates that companies detail their entire approach to coal ash management across its full life cycle for both their active and inactive sites. They have to lay out their environmental impact assessments, their strategies for avoiding waste in the first place, and their super strict disposal procedures. They even have to detail their incident remediation protocols. Like, what exactly is the plan if there's a spill? And how are they going to safely decommission these disposal facilities when they're finally closed? It is a full, cradle-to-grave accounting requirement for this hazardous material. Which really leaves us with this one big, vital question to think about. As our global energy grid continues to rapidly evolve, how is tracking every single metric ton of this ash going to reshape the legacy of coal? By forcing strict, quantitative metrics onto the grid's dirtiest leftovers, we're pulling these hidden liabilities out into the light. We are forcing real transparency onto the balance sheet. And ideally, we're incentivizing that incredible transformation from toxic waste into sustainable wealth. Thank you all so much for hanging out with me for this explainer. Keep asking questions, keep diving into the data, and I'll see you in the next one.